Hi everyone. Welcome to this new session where we are going to discuss the Python implementation of decision trees and random forests. In today's lecture, we will be looking at two different cases where we will be applying decision trees and random forests for in Python using Jupyter Notebook. And we will look at random decision trees and random forest as a classifier and also as a regressor. So when I say classifier, classifier means where we want to predict which class an output falls into. So whether something is present or absent, whether it's a cat or a dog, whether it is like yes and no type of question, we will refer to such kind of machine learning problem to as a classification problem. And where I want to predict as a continuous variable, where my target variable is continuous, like height, weight, price, or money, then we should refer to that problem as a regression problem. So we will be looking at both type of problems, one a classification problem and one regression problem using distinct trees in random forests. And we will be also look at one of the projects that will be a kind of a homework for you all. I want you guys to try that. And we will be also looking at the scikit-learn library for decision trees and random forest. What are the parameters and what are the documentation provided by uh, uh, what is the official documentation says. So let's start. Right. So first we will be looking at decision trees and random forests as a classification problem in Python. And like any other problem, machine learning problem, we would like to start with importing libraries. So we will start importing pandas, numpy, and matplotlib, because we also want to uh, make some visualizations to see how the columns are related. And also we should import seaborn as per requirement, and we will do this matplotlib inline so as to see the output in the just in the next cell. Uh, right. So this is the data that we will be using. It is called kyphosis CSV. I'll be providing you with this data file also. We are storing this file as df for pandas data frame. Let me just show you how the data looks like. So this is what a kyphosis dataset looks like. It has four columns. First column is kyphosis. Kyphosis is a vertical vertebrae or the spinal cord condition. This data belongs to a set of children on which the children were operated for kyphosis. So the age is the age of those children in months, and the number is the number of vertebrae columns or the vertebrae or the small portion of the spinal cord which were involved. So like three vertebrae were involved, four vertebrae are involved, or five vertebrae are involved. Start is the number from the starting of your neck, like which one was where was the operation started, right? So it's the fifth from the top, 14th from the top, first from the top. So it is the starting position of that vertebrae, right? So this data tells about like after operation on that particular child whether the kyphosis condition was present or absent. Okay, so it has like some data of like maybe 60-70 data points, and we using these columns we would like to make a classifier or make a model which will tell us, given the age, number, and start, whether kyphosis was present or absent after the operation. So so now df holds the data from this kyphosis data set. Now let's look at the head of the data. The head of the data looks like this. It has four columns as we saw earlier, right? So let's do a exploratory data analysis where we would like to plot all the columns with each other. So we will be using seaborn pair plot. I want to plot this data frame, and the hue is kyphosis. So I want to color my data points based on whether kyphosis was present or absent, and I'm using this color palette called set1. So in this graph we can see like all the columns are plotted with each other, right? So I see like the red ones are where the kyphosis were absent, and the blue color shows where the kyphosis was present, right? So with this we get a kind of simple visualization so that we can go ahead with our analysis. Now moving on to the train test plate, we want to develop or make a machine learning model for it. and we'll be using scikit-learn. We will be using scikit-learn library for doing applying machine learning. And we also know that we have seen this earlier, scikit-learn model selection. We need to import train test split so that we can divide our data into training data set and testing data set, right? So X is the set of features. Okay, so set of features, it contains all the variables except the target variable. So I will drop df dot drop this hypothesis column along axis 1. So all my data frame df except the kyphosis column becomes my feature vector, or my all the variables, set of variables, independent variables. And y, or my dependent variable or my target variable, is will be the kyphosis column, right? Then on this x and y, I will get these four variables, like mainly x train, x test, y train, y test, using the train test split feature of the scikit-learn library. Now to apply decision trees on this given data frame, we are using sklearn.tree. uh, we are using the scikit-learn library and the tree functionality, or the tree function from that. So I would request you to just go through the documentation of decision tree classifier, which I have already opened for you. So this is the sklearn.tree decision tree classifier, right? It's a decision tree classifier, as in it will help you to and designate a target class to any one of the classes, like whether in our case whether hypothesis is present or absent, or in any other case it can be like level 1, level 2, level 3, whether it's a cat, dog, or an elephant, or whether it's a male or a female, or yes and no. This type of a target variable can be used, can be easily modeled using a decision tree classifier. So here are some of the parameters that it takes into account. So we have already seen like criteria, which criteria. So we have seen entropy, Gini index. So we have discussed what is the formula of entropy. So it is like which criteria my decision tree should use to split on the nodes. Then like what should be the splitter, like best or random, right? So it says the strategy used to choose the split at each node. Okay, then what should be the maximum depth? I can define the maximum depth of the tree. Minimum sample split. So what is the minimum number of samples required to split an internal node? So all these different parameters, we should like I request you guys to go through all of them. We just understand. Once you go through all of this, you will understand, okay, what do they mean, what do they stand for, and how can we manipulate them to get a better result. Okay, now going back to our code, right? So because we will be using decision tree classifier. So from sklearn.tree, we will import decision tree classifier. Right now, the decision tree classifier has been imported in our Jupyter notebook. Then I want to create an instance of the decision tree classifier, or you can say I need to initialize decision tree classifier for our particular use. So I need to create a variable which will work as a decision tree classifier in our program. So I name it as D tree. And then I use decision tree classifier, bracket open and bracket close. This will instantiate or initialize an instance of decision tree classifier, which can be used to model or to make predictions about our given data, right? So now I want to fit this decision tree classifier on our data. So I will do decision tree dot fit x train and y train. When I run this, I get this output which shows which shows all the different default parameters. And it looks like we have fitted, or we have, like, within just these 2-3 lines of code, we have made the decision tree process, decision tree classifier or decision tree model for the given problem. Now it's time to make some predictions and check and evaluate our model for its accuracy and precision, right? So I'll make a variable called predictions, and we'll do dtree.predict and x test. So what are given the x test, what are the predictions that my d tree is making, right? So the predictions variable will store all of those predicted values for the unseen x test values, right? From sklearn matrices, we need to import classification report and confusion metrics to evaluate, to see how my model has performed. And I'm printing classification report for y test and predictions. So like what are the actual y values and what are the predictions my model is making. So I see that like the precision and recall is around is 80%, and which is like quite good only for the given data which I have. And if you I see the confusion matrix, like 17 plus 3, 20 times I'm making a correct prediction, but 5 times I'm not getting I'm making wrong predictions, right? So out of these 5 times, I am not able to 3 plus 2 5 times. We are making a wrong prediction. Like my model is saying it is present, but it is actually absent. Kyphosis is actually absent. So let's look at whether uh, now let's look at how can I improve the same result using some random forest, right? So just like decision tree classifier, I can import sklearn from ensemble, right? So decision tree was part of the sklearn dot tree library, but random forest classifier is an ensemble method, so it's a part of sklearn dot ensemble, and I can import random forest classifier. So I have opened it for you. Just make a just sklearn.randomforest. If you search it on Google, you should be able to get the very first link. And you can also look at the classification, right? You can also look at n estimators, like how many trees you want, what should be the criteria, what should be the maximum depth, minimum samples. So they all have default value, and you will be able to understand what do each of these parameter means, right? So that you can change as per your model requirement. Okay, so let's create I have imported random forest classifier in our program, and I want to instantiate the random forest classifier. So I have created a variable called rfc, stand for random forest classifier, and I am passing the number of estimators as 100. So for starters, I want 100 trees to be the part of my random forest classifier, right? Now I want to fit rfc on my x train and y train, right? I want to fit this particular random forest classifiers on my data, right, on the given data of kyphosis data set, right? So this is the fit. This output shows my random forest classifier, how does it fit on my given data, right? Now I want to go ahead with the predictions, right? And when I go ahead with the predictions, I see that rfc pred will hold all the predictions for the x test, rfc dot predict x test, right? And when I see the output, and it looks like almost the same, like exactly the same. So I make 17 plus 3 20 correct classification, and 3 plus 2 as wrong classifications. Maybe we can try to improve the number of n estimators here to get a better result. And I can print the classification report. It looks like this, like pretty much the same, right? So it like in this particular case, number of the random forest classifier does not improve the performance any better, but we can try to change the number of trees so that our performance improves. Okay, so this was the first case where we use random forest and decision trees as a classifier. Now I want to discuss a different problem where I want to use decision trees and random forest as a regression or a regressor. Okay, so of course we will start by importing all the required libraries. It's the basic or fundamental step. Now I want to look at the data. Let me show you what is the data that we want to work on. So this data is position, level, and salary. It's a simple data set which gives the name of the position, the level of the position, and the salary, right? So basically, what I want to do is, given the level, can I predict the salary of any employee, right? So in these two columns are important, and this the position column is not important because it's just a text column, and it does not hold any actual value, because the whatever the value this position holds is being considered by the level. So I want to predict the salary of an employee given his level, right? So if you have to make a decision tree for this particular data set, you can go about like this. So if the level is greater than 1 or not, first step. Then if it is less than 1, or if it is like less than equal to 1, your salary is 45. If it is greater than equal to 1, then again you have to go ahead and ask another question, whether the salary is less than equal to 2 or greater than equal to 2. Then you will have one more split, right? And after that, the next node will be whether the level is greater than 3 or 4. So these are the decision tree nodes that you need to follow, right? So for if I give you, suppose this is the level, what is the salary if the level is 7, right? So you can refer to this data set, and you can say, okay, if the level is below 7, then the salary has to be around 1,50,000, or if the level is more than 7, the salary is more than 2 lakh. So like this, we can make a mental decision tree. And for the same situation, how can I make a decision tree? Right. So let's import. So my dataset variable will read this CSV, which I just showed you. Okay, and the X column will contain all the data set, all the rows from the second column to the, and don't include the third column. So basically, the X variable or the feature vector will only hold the level column. Okay, level column. We are not including the first column because it is just a textual column. It does not hold any value. And my y column will hold only the target variable, which is my salary. What should be the salary? So all the rows of the last column. -1 represents last column, and dot values means give me the values. Right. Now let's start with training the decision tree regression model on the whole data set. Right. So I want to make a decision tree regression. So I want to import from sklearn.tree, import decision tree regressor. I have opened it for you. So this is for decision tree regressor. So the only difference is decision tree regressor will give you an output in a continuous range instead of giving you a class, yes or no. Instead of giving yes or no, present or absent, it will give you a number, okay, which can be like height, weight, or salary. So in our case, it is going to be the salary. So it, like, most of the parameters remains the same. You can go through the documentation, right? So the regressor variable is instantiates the decision tree regressor, right, with some random state. So you can keep the random state anything, but if you want to get the same results as mine, you also should keep the random state as 0, right? I want to fit this regressor to my given data and the target variable, right? So this lines fits the uh, 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 decision tree regressor on my given data, right? Now I want to make a prediction. So I want to make a prediction like if the level is 6.5, what should be the salary, right? So I will do regressor dot predict, and inside this, see, I have passed two brackets. This means I have passed two brackets because the predict regressor dot predict method takes the parameter as a two dimensional array. So that's why I have passed two brackets, right? So this indicates it's a two-dimensional array, right? So 6.5 value, I'm getting this output as 1,50,000, which I think is almost correct, right? So now let's visualize the decision tree. How does it look like? So I'm creating a X grid, which is like a np dot range, np dot a range, minimum x to maximum x in a state of in a step of 0.01, right? So my x or my x-axis is going to be from the minimum x value to the maximum x value, right? My x is what? Level. So from 1 to 10 in a step of 0.1, right? And I want to reshape it to the length of the x grid. So length of the x grid is going to be what? 100, right? So I am breaking my x-axis into small steps, small grids, right? Right. Then I want to plot a scatter plot of x with respect to y, right? Color should be red. Then on in the same thing, I want to plot x grid and a regressor dot predict x grid, right? So x grid is like the actual values of the level, and this the y values will be the regressor dot predict, whatever my regressor predicts the y values, and color should be blue. So blue line is my prediction, and the red ones are my actual values, right? Then I can set my labels anything as whatever I want. So this is what my output looks like. So given the position, what should be the salary? So blue ones are my predictions, right? So if your salary is between like 1.5 to 2.5 or one, this is you're going to be your salary. Like blue ones are the predictions. Blue ones are looks like continuous because I am making predictions for all of them in a step of 0.1. So between 1 to 10, after every 0.01, so like 0.1, 0.01, 0.02, 0.03, 0.04, 0.05, for all of these points, make a prediction, right? This thing means make a prediction for x grid, because x grid contains what? It's a range which goes from minimum x to maximum x. Just to make a more continuous graph, we did like this, right? So all of these red points are the given values or the observed values from the data set, and the blue ones are the predictions that our model is making. So like our prediction is doing really great because like at every level we get a step. So at every level we are doing a split, right? So maybe like it starts from 7.5 to 8.5, then this is like from 5.5 to 6.5, right? And our model is performing really great because like my predictions actually follow all the observed values. So this is one example of decision tree regression. Now I want you guys to show an example of random forest regression on the same data set, right? So we will start by importing all the necessary libraries. The x and y values remain the same, and instead of doing fitting a random decision tree classifier or decision tree regressor, I am fitting a random forest regressor from the sklearn.ensemble library, and number of estimators I'm using is just 10. So I want 10 trees in my random forest, and I want to estimate what is my predictions, right? So regressor dot fit x dot y, and I'm predicting for the values of 6.5. Same, I am getting the answer to be this time. And when I plot this, the graph looks like this. See, it has more number of steps because I'm using more number of trees to predict for each of the position levels, right? So in this way I can use a random forest regression to make some predictions. Okay, now I want you guys to go through all of this code and come up with all your doubts and any clarification that you might need. And I have this small project for you guys to do, which is based on, so it's a lending club data, lending club, like, which is lending money to companies and to other institutions, and it is keeping a record of all those people who are defaulting on their loans, who are not repaying their loans. So how can you go about that, right? So this is what it looks like. I want you guys to make some this project. The data looks like this, right? It has all kind of columns, right? And you have to predict whether, like, it is fully paid or not fully paid, right? So please go ahead, watch this lecture. I will share all of these code files with you, and please go through the sklearn library documentation for decision trees, classifiers, decision tree regressors, random forest classifier, and random forest regressors. Okay, now I'm going to stop share at this point. Thank you for your time.